at some extension questions. This is extension, so it's basically looking at more at the 9A, what you do in a 9A course. And yeah, we're just going to work through these questions, and it may help you tackling those trickier questions later on. So the first one is find the equation of a line of gradient 2 that passes through the point -2, 5. So first step, y is equal to mx plus c. We know that the gradient's 2, so we can replace it with 2x plus c. Now we need to work out the y-intercept. To work out the y-intercept, we can use substitution. We know when x is -2 and y is 5, then we can plug those in and figure out what c is, and that makes our y-intercept. So here we go, we're going to plug those in. Y is 5, x is -2, plus 4 to both sides. We can see c is equal to 9 there. So what's our final equation? 2x plus 9. That's it. Let's have a look at the next one. Find the equation of a line of gradient -3 on 2 that passes through the point 8, 6. We just do the same thing here. Y is equal to -3 on 2 x plus c, and then we substitute our x and y values in. So we're saying that y is 6, x is 8, and we know that 8 and 2 cancel and make 4, so we've got -3 times 4 plus c, -12 plus c, plus 12 to both sides. 18 is equal to c. Rewrite our equation. There we go. So that's how you tackle those questions. Rule of thumb, start off your equation, sub in either your m or your c, then sub in a coordinate to find the remainder. Hopefully that was useful. Now we'll be looking at finding gradients using points. Now with this one here, it says find the gradient in the line joining these points. Now there's nothing wrong with just drawing the coordinates, okay? And this is the strategy I'd probably recommend doing just to start off. And then 4, 9. And then going, okay, I want to find the gradient between those 2 points. So it's going from -1, x is -1 to 4. So how much did it go across? -1 to 4, it's gone across 5. And then it's going up 6. So gradient is equal to rise over run, and it's positive, and we keep it like that. That's probably the best strategy I'd recommend for the time being. There is an equation you can use, which is m is equal to y2 minus y1 on x2 minus x1, where this is your first coordinate, x1, y1, and this here is your second coordinate, which is x2, y2. And you can plug those values in. So I'll show you how it works. M is equal to, well, y2 is 9, y1 is 3, and x2 is 4, and x1 is -1, 6 on 5. So both of these ways work. You can choose either. Okay, now it's rearranging. Now this is the last example we're going to have a look at, but this is probably one of the more important skills for high level maths, is being able to manipulate equations and rearrange them into different forms. So this one says 2x plus 3y is equal to 8. We want to get into y is equal to mx plus c forms, and therefore we can state the gradient. So we can acknowledge that it's pretty hard to know what the gradient of this is at the moment. We could try sketching it using our x and y intercepts, but we can rearrange it into y is equal to mx plus c form and then just say what the gradient is because it's the m. So first step, let's see if we can do that. 2x plus 3y is equal to 8. Now we want to, as our aim, make y the subject, which means by itself. So I'm going to take 2x from both sides. Now picture these as blocks. Okay, so I've got 3y is equal to 8 take 2x. Now remember how I said these are blocks? That's meant to be green. You've got a positive 8 block here, and you've got a negative 2x block here. I'm going to swap these round like this. That's absolutely fine. Reason for that is usually it's y is equal to mx plus c form. Next is I don't have y by itself. Technically, what's in front of this y? It's 1y. Currently, I've got 3y. How do I get rid of a 3? I divide it by 3. What I do to one term, I do to all terms. Here we go, y is equal to negative 2 on 3, x plus 8 on 3. We can now answer our question. What's the gradient? The gradient's always in front of the x value. So the gradient m is equal to negative 2 on 3. I hope you found this video useful for extension questions. These are usually the pricklier ones that you'll find in 9A. Thank you very much.